Okay, gang, I believe this will be the last section, the last topic for this section, which is average and instantaneous rates of change. So when you do the homework, that's going to be over here towards the end. Average and instantaneous, I'm giving you 97 and 98. Alright, so I've just made up an example. I like to ask this one on the exam. Test 2. So let's give this a go. So average rate of change is what you would do in like an algebra class. So an average rate of change is y2 minus y1 over x2 minus x1. That's just your basic slope, your average. Now the thing is you're going to be given an interval. And remember, an interval is just where your x values start and where your x values end. So this is not a coordinate. So you actually have to find the y values to plug in here, right? I have the x1 and the x2, right? I have that part, right? x2 is 2. So I have the 2 minus the 1, but I don't have the y2 and the y1. So you have to calculate that. So let's start with the first y value. So to find the first y value, you'd have to plug 1 into the function given. So 1 squared plus 5, that's 6. And then the second y value would be from the second x value. So this would be 2 squared plus 5. This would be 9. 4 plus 5 is 9. Okay. So this would be equivalent to like my y2. This would be my y1. So this would be 9 minus 6. So we'll get 3 over 1 or 3. So this is the average rate of change. So on your next test, just remember that you have to find the first and second y value so that you can finish the finding the slope for the average. Now, instantaneous rate of change is calculus. That's your derivative. So this means derivative. And I have to slightly alter the question because the derivative just takes one input. So I want you to find the instantaneous rate of change on each of the endpoints of the interval. So that would mean you're finding two derivatives. So the first thing we're going to do is find the derivative. Let me just move the function down here. So we're going to use the power rule for this. So the derivative of x squared using the power rule is 2x. The derivative of a constant is 0. So this is the derivative. So now I'm going to evaluate the derivative at each of the endpoints of the interval. So here again are the endpoints of the interval. So I'm going to do f prime at 1. So that's 2 times 1. Right, I'm plugging it in here, which is 2. So the rate at the beginning of the interval is 2. Now I'm going to do it at the end of the interval. So f prime of 2. I'm going to plug it into the derivative. 2 times 2 is 4. So that is the rate at the end of the interval. So you could tell the object is going from a rate of 2 to a rate of 4. So the object is speeding up. Alright gang, that is it. Best of luck with the homework. Give me a holler on email if you're stuck on anything, okay? I'll catch you. Bye-bye.